About a month after the dwarf planet Ceres was discovered in January 1801, it vanished behind the glare of the sun. The mathematical tools of the time were not capable enough to predict its location, leaving astronomers stumped when Ceres failed to appear when it should have. One mathematician came through with a solution. He worked intensely for 3 months and eventually predicted the position of Ceres in December of the same year. His prediction turned out to be accurate when Ceres was rediscovered on the 31st of December. That mathematician was Carl Friedrich Gauss. He had utilized a novel method in his work on the discovery of Ceres, the method of least squares, a notable treatment used to this day to minimize errors. His work laid the foundation for the field of celestial mathematics. Aside from astronomy, Gauss has made significant contributions to many fields of mathematics and science. He is considered to be one of the greatest mathematicians and is ranked among history's most influential ones. Although we witness Gauss's influence in mathematics through our coursework, what we may not know is that Gauss was a child prodigy. His exceptional talents were recognized early by his teacher, who allowed him to work on advanced mathematics. By his early teens, he had already performed astonishing proofs, a notable one being a breakthrough in a geometrical problem regarding polygons, a problem that had bugged mathematicians since the days of the ancient Greeks, which he achieved at an age of 19. He completed his magnum opus Disquisitiones Arithmeticae at age 21. Gauss produced the fundamental theorem of algebra and made important contributions to geometry, statistics, and number theory, wherein he introduced the triple bar symbol for congruence. He is also credited to invent the first Fourier transform algorithm. Gauss's work were vast and varied. Other areas he worked in were topology, terrestrial magnetism, and cartography, among many others. He developed Gauss's law of magnetism and made important contributions to the study of electricity. Furthermore, he invented the heliotrope, the magnetometer, and the first electromagnetic telegraph. Gauss was ranked among the most influential mathematicians of history for good reasons. His contributions remain significant and relevant to this day and continue to inspire modern discoveries. His works in orbital prediction simplified and improved the complex mathematics of astronomy that was being used in the 18th century. His contributions were so significant that they still form an integral part of astronomical computation today. His discovery of non-Euclidean geometry significantly altered the way mathematics was viewed, freeing people from the notion that Euclidean geometry was the only way to make geometry consistent and non-contradictory. Gauss was known to be a perfectionist and a hard worker. Despite that, he was not prolific, and he refused to publish any work that he did not consider to be complete and above criticism, keeping with his personal motto, few but ripe. He was known to be meticulous and would often spend years working on a single problem until he was satisfied with the results. His personal diary indicated that Gauss had made several significant discoveries years or decades before other mathematicians had published them. It is believed that if he had published his discoveries in a timely manner, he would have advanced mathematics by 50 years. Gauss valued the pursuit of knowledge, as stated in one of his letters dated 1808.